Okay, let's work an example problem, shall we? So we've been talking about pressure changes in a column of fluid. We've introduced the idea of a manometer. So let's do this. Let's have basically a kind of a lake with a U-tube manometer attached somehow to the bottom of it. So either like a lake or a tank, some body of water, we'll say. So this could go on as I mean, this could just be a tank, it could be a lake, some standing body of water. This side's going to be open to the atmosphere. All right, that's that symbol there. And then down at the bottom down here, you've got a U-tube manometer with another fluid in it, some unknown fluid. Now this unknown fluid is going to go up higher than that water column is. Now this one's also open to the atmosphere. And the elevation change here for the water, this again, this is water in this side. This will be 5 meters on this side. And then over here, for the unknown fluid, this is going to be 8 meters. Right? Again, some unknown fluid. Now, for me in my class, when you're working examples, when you look in the book, there's going to be like a long, maybe a 2 or 3 sentence paragraph explaining that it would probably say something like a body of water 5 meters tall and open to the atmosphere has a U-tube manometer coming out of the bottom of it. And in the U-tube manometer is an unknown fluid, and that unknown fluid goes up about 8 meters. And the other side of the unknown fluid is also exposed to the atmosphere. And then the problem is going to say, determine the unknown fluid density, or determine the density of the unknown fluid. Now, you are more than welcome to copy the entire paragraph that is the problem statement. You're more than welcome to write it out by hand. You're welcome to copy it and paste it and print it, and any number of ways you want to do that, if that is helpful to you. Really, at the very least, though, if you'll just write what is it that you're looking for? What is the problem statement? What do you need to know? That it becomes your anchor because we're gonna get this one done pretty quick, but a lot of problems will end up sometimes multiple pages. And so you'll find all kinds of intermediate calculations. At some point, you'll be like, what the heck am I looking for? If you can come back and say, oh yeah, I'm looking for the density of an unknown fluid, then you can come back to that. Now this is going to be lecture 2. This is my third page. I think it's going to be third of 3 is going to be my guess. And I'll go back and number those other pages. Um, Now, so what do we know here? Well, given, right? I've got some z values. So I'm given some z's. I'm given uh, p atmosphere in a few places. I'm given the fact that I have water. Now, normally I can write these out as kind of like numbers. I can say, well, Z1 is equal to 0 and Z2 is 5 meters, or something like that. So normally I can do things like that. Here, it's not really defined. I just have a picture that I have to kind of figure out what am I going to use. So we talked briefly at the end of the last video about problem solving, and this is what I'm trying to find, right? This is what I'm trying to find. So I'm trying to organize what do I know? I've got a picture of it. So if I've got a picture, go ahead and draw that in your notes. That'll force you to kind of process that information and really think about what is known and how do I organize it, which is really, it's very easily overlooked, especially if you're cheating and using a lot, well, I won't say cheating, but if you're using a lot of AI or something like that to do the problem solving for you, you're not going to get the subtlety of how important this process is of organizing the known information. What do you know? Now, what tools can we use? What are the fundamental laws, rules, or relationships that will help us find what it is that we're looking for? Well, what is a fundamental law, rule, or relationship that applies to this type of phenomena or this type of situation? So I've got a column of fluid here, and I've got a column of fluid there. And I know some pressures and I know elevations, which means I can describe how that pressure change I've got this fundamental equation that says the pressure change in a column of fluid is equal to the density of the fluid times gravity times the change in elevation, Z1 minus Z2. If it's P2 minus P1, then it's Z1 minus Z2. I could do P1 minus P2 over here, so long as I do Z2 minus Z1 there. Now, what do we call 1 and 2? Well, actually, I have three surfaces. I've got one here, I've got one there, and I've got one there. So you can call them 1, 2, and 3. You can call them A, B, and C, whatever you want to call them. Here we're using generic labels of 1 and 2, and we could stick with that. But I'm going to have three surfaces that I need to be aware of here. So if I call this point 1, I call this point 2, and now I've got point 3. Now notice this equation doesn't go to three different points. Well, what it does is it describes between 2 points, given the density of one fluid, I can describe the pressure change. So what that means is I can use this equation to figure out what the pressure is here. And then note that this point right here is at the same elevation. So the pressure at this point is equal to the pressure at this point. So if I know the pressure at this point, I can use this same equation to figure out the pressure change from here to here. And the only unknown becomes the density of the unknown fluid. So what I can do is I can say, well, you know what? I've got between points 1 and 2, I've got water. So I've got the density of water times gravity times Z1 minus Z2. So this is one equation, but notice I've got, sometimes it's helpful to circle your unknowns. What have I got for unknowns here? I'm going to circle it in red. I don't know P2, and I don't know, I'm sorry, I do know, um, what is not known? Well, I've got one equation, one unknown, actually. I do have this unknown, or I can find this unknown, so I can solve for P2 there if you like. Um, but what am I actually looking for? Well, I'm looking for the density of the unknown fluid. So I could write an equation between points 2 and 3. I could say P3 minus P2 is equal to, it's the unknown fluid between points 1 and 2 times gravity. And then if I'm doing 3 minus 2 here, this needs to be Z2 minus Z3 there. Now, what's unknown here? Well, what's unknown is P2 and my unknown density. I know the density of water. That's known. I should not have circled that in red, but I did. That's my mistake. I'll make those sometimes. But I got here two equations, two unknowns. I don't know P2. I don't know the unknown density. But what is the problem asking for? The problem's asking for the unknown density. So I've got two equations, two unknowns. I always like to say the engineering work is done at this point. The hard work's done. Um, Now it's just math and units. But I do need to make sure I've got a good handle on what is Z1, what is Z2, what is Z3. Well, Z1 and Z2 and Z3 are the elevation at these different points. So what do we want to call these? Well, what we can do is we can say, well, here's Z2 is down here. Z1 is up here. And then Z3 is all the way up there. Now, what I normally do is call one of them 0. You could call any one of these three 0 and set all the others relative to that. Everything below the 0 point is negative. Everything above the 0 point is positive. Now, there's no wrong answer here, but what I like to do is pick a point that everything can be measured relative to. Well, notice Z1 is measured relative to Z2, and Z3 is measured relative to Z2. So that, to me, says Z2 is a good candidate to be 0, because everything else can be measured relative to that point. So if I do that, that means Z1 is equal to a positive 5 meters, and Z3 is a positive 8 meters, because they're both above the 0 point. Now, there's nothing saying I couldn't say Z1 is 0. If I said Z1 is 0, Z3 is 3 meters above that, so Z3 would be a positive 3, and Z2 would be 5 meters below Z1 of 0, so Z2 would be a negative 5 meters. And mathematically, that's the same thing. When I plug those values into these two equations, I would get the same final answer. But notice now I've got numbers, I've got actual values for these. These are all known. The Z's are known, gravity is known. The density of water wasn't given to us, but we can make an assumption I said a few videos ago that it's always safe to assume that the density of liquid water is about 1,000 kilograms per meters cubed. Now, I did say after chapter three, be very careful making that assumption because after chapter three, I'll have the tools I need to determine is the water in liquid form because it's not a guarantee after chapter three. In fact, a lot of times it won't be in the liquid form. So, but if I make this assumption about the density of liquid water is about 1,000 kilograms per meters cubed, so that is now a known value. I checked it earlier. It is in fact, we're going to make the assumption that's a known value. I'm looking for the density of the unknown fluid. I've got two equations, two unknowns. Now it's just solve, right? How you do your algebra to get to the density of the unknown is entirely up to you. If you want to find the numerical value for P2, plug in all the things we know over here because we know that, oh, by the way, P1 is equal to P2 I'm sorry, P1 and P3 are essentially one atmosphere. We can make that assumption. It's not really an assumption because that's given to us, right? We'll say P1 and P3 are both known. They're open to the atmosphere. So the pressure at those points are in atmosphere. So how you find P2, if you want to find it directly, because I can plug in all these numbers here and calculate it. I'm going to use algebra skills that I got because I don't mind using them. So I'm going to say, well, you know what? P2 is equal to P1 plus the density of water times gravity times Z1 minus Z2. Now, I could find it. I've written that below here where you can't see it. I apologize. I can find this value here, but I don't need to. In fact, what I can do is I can plug this in right here. And I can say that P3 minus this quantity, P1 plus the density of water times gravity times Z1 minus Z2. That's going to equal this unknown density times gravity times Z2 minus Z3, right? And since P1 is equal to P3, these are going to go away. But I do need to distribute this negative sign, right? So I've got negative times this and negative times that. So it's going to be minus the density of water times gravity times Z1 minus Z2 is equal to the unknown density times gravity times Z2 minus Z3. And again, I've got this negative sign here. It needs to be applied to both these. P3 minus P1, since they're equal, those go away. That's just zero. So I've got minus this guy. I'm going to distribute the negative sign in here. I'm going to get rid of the gravities because they're the same on both sides of the equation. I'm going to distribute the negative sign into Z1 minus Z2. So now it's going to become the density of water times Z2 minus Z1 is equal to the density unknown times Z2 minus Z3. And I'm trying to find the unknown density. Unknown density, I'm going to group the z's together in a single ratio. So it's going to be Z2 minus Z1 divided by Z2 minus Z3 times the density of water. Notice I've not plugged in numbers until the bitter end. I'm down to the point where I know all of these. I've solved for my one unknown, and I can go ahead and write it out. I don't plug in numbers until the bitter end because I don't like writing numbers and decimal points and units to keep track of them until I just absolutely have to. I know that might be a bit different for some of you guys if you're not practiced at that, but I assure you, you're going to save yourself a lot of writing if you'll get in that habit. You don't have to. You can plug in numbers all the way back here, right? You go ahead and plug in numbers all the way back here and just write the numbers and the units all the way through. You really don't even have to write the units, but I will tell you from experience, you're going to make mistakes. And a lot of times they're going to be unit mistakes. And if you'll write your units throughout your calculations, it's going to be a lot easier. You're going to spend a lot less time trying to figure out where you made a mistake. By doing that. So I'm trying to save you some time, but if you need to learn that lesson on your own, feel free to not write your units. I'm going to write my units. So what do we got here? Z2 we've said is 0. Z1 we've decided is We can go all the way back up here, right? Z2 is 0, Z1 is a positive 5 meters, and Z3 is a positive 8 meters. So Z1 minus, I'm sorry, Z2 minus Z1 is 0 minus 5 meters divided by 0 minus 8 meters times the density of water is 1,000 kilograms per meters cubed. This is a negative 5 meters divided by a negative 8 meters. That's a positive 5/8, and the meters go away, times 1,000 kilograms per meters cubed. Normally, I would say have your calculators out and do these. This is a number I can kind of remember. 5/8 is 0.625. It's just a little more than a half. Times 1,000, it's going to be about 625 kilograms per meters cubed. I don't expect you to do that in your head. If you can, great. That's what you have a calculator for. But have your calculators next to you. Even your phone calculator is okay when you're taking notes for in class. If you're sitting in class with me, I have everybody have their calculators out. I won't have these intermediate numbers. I'll say, run these numbers, and we'll go by consensus until the majority of the class kind of agrees on a number. Okay. That's a nice example problem. Hopefully get you started on your manometers. There is a way I can write this as a single equation, not go through the process of writing two equations. You're welcome to learn that. I've just learned over the years that I can explain this real simple, right? I've got one column of fluid, write one equation. I've got another column of fluid, write another equation. Set your z values up based on some zero value. Everything above that's positive, everything below that's negative. You can write this as a single equation, but you got to remember a lot of rules about when it's positive, when it's negative, where do I start, where does it go, what do I do, and if you're comfortable learning all those steps to write this as a single equation and not go through the process of substitution, that's fine. You should have the algebra skills though. This is a very simple substitution to make to get to here. How you do your algebra is fine with me, just don't break any algebra rules. Okay. All right, that's a good video. I'm going to stop it there and post this one.